Hello and welcome to our next C++ tutorial, and today we will learn about pointers and memory management. So pointers are variables that store memory addresses. They allow you to directly access and manipulate memory location, providing efficiency and versatility. Why use pointers? Imagine needing to work with large data structures, dynamic memory allocation, or parsing parameters by reference. Pointers enable us to handle these scenarios efficiently by referencing memory data rather than copying data. Basically, we use a pointer to point to a variable. A pointer would simply store the address of the variable, and then it would directly point to it. Instead, we have to make different variables to copy different variables to copy other variables. So let's see in this example. We have a variable name that's named 42, and its value is name is number and its value is 42. Then we have a pointer. We declare a pointer by putting up this asterisk sign and then the name of the pointer. You can make it anything. It's not just limited to PTR. You can make it any number. You can even name it something other than this, like something like this. You can do some like anything. For now I'm just gonna keep it pointer PTR. Okay, so basically this is how you assign the address of number to the pointer. Basically it kind of keeps the value of this, but it's not exactly that. Basically every variable in the program, when it runs, has an address, and basically what the pointer does, it copies that address and assigns it on itself, and then we can basically use that to in all over our code. So we have assigned the address of num onto the pointer. So we have some console outs over here. We console out the value of num, and then the address of num, then the value of pointer PTR, and the address of pointed by PTR. Okay, so let's run it and see what we get. Okay, so as you can see, we have the value of num PTR, which is like a value of the num, and which is 42. Then we have address of the num. Okay, basically we specify the address by putting the reference assignment. Basically this is a reference operator that we use to assign the address of the variable onto a pointer. So after that we have the value of pointer PTR. Basically this is the, if we want to output the address of the pointer, this is how we console out it. Over here just put the PTR, because this basically contains only the this is only like the it has only the address, because we have only assigned the address to it. But if we point on to from to the address to the exact value, we would get the answer, and for that we use the asterisk again, just like we used it over here in the declaration. So we use that to point to the value where that address was takes us, because like for example, like let me give you an like in real life example. So like for example, you have your friend is coming over to your house. You basically tell him the address that your house is there. Before like coming over, he would like think his house is at this street, that street. So basically that's the value of pointer PTR, that is the address. Okay, so when he comes there, he sees you, and he's over at your house and sees you, so that becomes the value of the PTR. Basically you're at the address. For example, you're the in the example you are the value, and the PTR is the address of the place. Okay, so basically address is basically pointing on towards the value of the object or the variable. So this is how the simple pointers work. So then we have, after all this, we have dynamic memory allocation. It is one of the powerful features of pointer. Let me explain what dynamic memory allocation is. Dynamic memory allocation is a crucial concept in programming, especially when dealing with situations where you need to allocate memory at runtime. Basically, when you run you have to run the program, you have to allocate the memory to a specific amount of memory to the program. So unlike static memory allocation, basically allocate the memory at a exact thing, exact memory amount, we can basically where the memory is allocated at compile time, when it is compiled and tied to the lifetime of the variables. Dynamic memory allocation allows you to allocate and deallocate memory during the program execution. Like when the program runs, we can allocate or deallocate. Basically, we have, for example, I have I have an if clause. Okay, if num is equal, okay, num plus plus. Okay, if num is equal to 43, okay, we delete PTR. Okay, so after that, delete PTR and cout PTR. Okay, so let's see what is going on here. Okay, so basically what has happened over here is that we have increased the value of the num to 43. So now if the num is 43, we delete the PTR, and if we see out PTR, we get nothing because there's nothing inside the PTR, and the memory the total memory that was allocated in the PTR is 0. Basically, over to this point, to the this point, there was memory allocated to this variable. Let it will show, our compiler will show the 4 bytes was allocated to this, 8 bytes was allocated to this, total of 12 bytes. So this was a declaration, and this will take some memory as well to store some data and to show on to during the compilation and the runtime. So after all, this was 12 and let's say 20 bytes were allocated add to this point, till this, we have made a condition that if the value of num increases to 43, we delete the PTR, which basically just frees the memory and increases the amount of memory that is available. Then we there's is pointed to a deallocated memory. As you can see, the local variable PTR may point to a deallocated memory. There's no there isn't anything on PTR anymore because of the we have deleted it. So this is how dynamic memory allocation works. So why would we need it? Sometimes you may not know the exact amount of memory needed for data until runtime, because when you run your data, before running it, you can't I was just estimating how much data, how much memory this would this would need, these all would need, and I'm not sure how much would this function would need it. So basically, and how much would this need. So basically, we don't know how much memory, exact amount of memory a program needs until we run it. So for instance, I want to store data in arrays whose size is determined by user input or other runtime factors. this is where memory allocation comes to play, because like if I set the size of the array that is which is specified by the user, it would be hard to say how many members of the array the user is gonna add. He might add 1,000, he might add 1,000,000. It depends on the user. So for that we don't know how much we need. So basically this helps in dynamic memory allocation. In C++, the new operator is used for dynamic memory allocation. It allocates the memory from heap. Heap basically is a region where memory were used for dynamic storage, and returns the address of the allocated memory. It is important to note that when you allocate memory using new, you are responsible for releasing that memory when it's no longer needed. Basically, if I create a new variable with new variable, it's my responsibility to delete it before it reaches to a point where it fills up our whole RAM, instead of just like keeping it in the program if we don't need it, when we like don't want it to run. So it's our responsibility of a developer to delete when it's not in the use. So let's see an example of dynamic memory allocation and deallocation of it. So let me put the code over here for dynamic memory allocation. So we have a pointer named dynamic ptr new equal to new int. Basically we're dynamically allocating the memory over here. Okay, the value of the ptr, the pointer, is 123. We're storing the value in the allocated memory, and then we're making the displaying the value, and then we're just deleting. It's simple code, making, storing, outputting and deleting. That's all we're doing over here. But we're basically making it equal to new int, basically dynamically allocating memory. What this whole statement means is that we're saying that in this pointer dynamic ptr is a new integer that will take 4 bytes of storage, and then we can store like our any like integer that we want. If we do new double, as you can see, cannot initialize a variable type int with an r value of type double, basically return value of type double. So basically this is what it returns. Basically what we're saying is the int dynamic ptr int pointer dynamic ptr is returning a new variable double. Okay, so if I make it this double as well, it says there is no problem. Okay, the client ID is saying use auto when initializing, then with new to avoid duplicating the same type name. So we can basically do is auto, or what auto is like basically assigns the string, basically assigns the variable type automatically. It does the thing for you where you have to automatically go manually go ahead and type int and all that. It just does it on its own, looking at the data. So basically if we had like something other than this, like we can do this new auto, but it would give an error, and the new expression for type auto requires a constructor argument, so we can use that without a constructor. Okay, so we have the auto dynamic ptr pointer is equal to the new variable double. So let me do a float would be better. Let's do float. So 12.3, we do that. Okay, so it like basically outputs the value of the dynamic ptr, and then it deletes it to deallocate the memory, to free the memory. So This is how we can allocate and deallocate memory. Now we're gonna talk about memory leaks and deallocation. While dynamic allocation is powerful, improper memory management can lead to memory leaks. Let's see how it works. Okay, so let me put a code here. We have a code that is int pointer, memory leak pointer, and new int. Basically the return is new int. What is missing over here is delete memory leak ptr. What it, because of the like commented out this thing, it will cause memory leak in the whole code. So let's see out memory leak ptr. So let's see. So basically it just has a random value. So before I move on forward, let me explain you what even memory leak means. Okay, so memory leak is basically a situation in programming where a program fails to release memory that it has allocated dynamically, causing that that memory to remain inaccessible even after it's no longer needed. Okay, so over time repeated memory leaks can lead to gradual consumption of available memory. Basically memory leak means that we did not deallocate the memory, we didn't delete this pointer. So basically it's causing these variables, this pointer and all that, to keep on just staying in the RAM and hogging up all the RAM. This basically, you can say, like you have a small bag, you keep all your things, books, laptop and all that, but then you have some garbage in it, which hogs up a lot of data or a lot of your space in the bag. So basically you didn't delete the garbage from your bag, so it would take up some space, that the new things that can come, basically like you moved on to a next class but you have some garbage that you don't didn't clean, so you can't really move on without cleaning it, and you can really put your new books into it. So this is what memory leak means. Okay, so after that let's learn about pointers and function. Pointers also play a vital role in function calls. They enable function to modify values directly and return multiple values. Basically we can modify values directly from we can keep on returning multiple values from the same, like using the same pointer, instead of just making new variables again and again, which can become quite tiring for the developer. We can basically just modify that value again and again and keep using it. Basically it increases the reusability of the the variable, instead of you just making the variables again, which no one really likes to do the long and procedure. So I have a code over here which is has a function void modify value, has a pointer as the argument, and we are assigning the value of pointer as 99. Okay, so we have int number. Before we modify it, the number would be output on the code on the console. So after we run the whole thing, we put the we use the reference operator, and then we put the variable in the variable, and after that we can just modify it using that. And I can keep doing it as much as I can. I can go ahead and put it back to that, and then modify. Let me num, and let's do 100. Okay, let me do again, and it will do this and that again, and we output that the number and there. So if we run this, as you can see, first we had 10, okay, then after the modification it got to 99, then I changed it in the code to 100. Instead of making a new variable then assigning it to that and then outputting it, I just changed it out there, and then we got 100. Then we use the same function to change it back to 99. So this is how pointers in function work. It makes the code very much reusable, and it makes it very helpful for the developers to just keep reusing the same variables if they want to, because the name of the variable can matter a lot. Like if you want to keep the same name of the variable rather than just keep on changing it again and again, because this variable is you're going to need it again in the code, the same name of the variable for the coding purposes, you're gonna keep that variable name. So this is how pointers work in function. One thing to note, why we use this reference point operator. We used it before because if we didn't use it, let's see what we get. No matching function for call to modify value. Basically the function wouldn't this function call wouldn't match any of the function that is in the code. Basically this function only accepts pointer variables, and if we put reference operator, it would basically means that it is referencing towards this pointer, that the parameter of this function is this variable with the reference, and then it will assign it onto that. So this is how the functions work, the pointers work with functions. So the best practices when working with pointers is that initialize pointers to null pointer or null before use. Basically just make it 0 before using, initialize it as 0. If you make a pointer inside your code, int pointer ptr, remember to make it 0, because it's gonna be set to some random number if you don't initialize it to 0. Next is always check if pointers are valid before dereferencing them. Then release dynamically allocated memory using delete, use this. Basically use the delete to delete the variables like number, string and all that, or use delete this one to do this. It's up to you, you can use any of them, it's not a big thing. Consider using smart pointers for automatic memory allocation, memory management. So in the end, the pointers are the cornerstones of C++, providing direct memory access and control. By mastering pointers, you gain the ability to work with memory efficiently, allocate memory dynamically, and interact with functions more powerfully. So this is all about the pointers that you needed to know. Just to understand more freely about these pointers, you need to practice it yourself, because in the coding you have to practice a lot to master any coding language. Without practice you cannot really master it at all. So this was it for today. I hope to see you in the next one.